So let's go. Okay. All right, are you guys done with your little side story?
Yeah, I'm good.
Okay. I was gonna say, it's on YouTube now, so if you want to share, now's your time.
Oh, we're just talking about like how Canadians go into Bloomington, and like Indiana University is in Bloomington, and like it's well known. You might just go down there and see what's up, like or something.
This is not what you were just talking about. Okay, moving on. Max. All right, we have to do letter D, which we've done A, B, and C. Am I correct? We were a little bit off with A period, with alpha, so I want to make sure that we were all good. So we did all of these graphs yesterday. All we did were transformations, and we're going to keep working on that. I left kind of a hard one for us to do today. We have to do letter D. So my question to you, and my question on all of these is just like, how do we get to the next thing? What is my changes? So what does this negative do to my graph? Flips it how? Show me how it flips it. Use your hands.
Oh.
That's my x-axis. Flips like this. Flips over my x-axis. Or like sometimes you guys do this. Whatever way, we're going like from on top to on bottom. We're flipping like that. So we're flipping across the x-axis. And so which does that affect? My x or my y?
X. Y for sure.
Y for sure. We do -1 times y to find all those new y values. Now, these absolute value signs, though, they add something to the table, too. Does anyone remember what those do? Not y's, x's. We have no negative x's because the absolute value is only around my x. That means I'm going to do a mirror image of my positive y's. No, x's. Sorry, I'm getting all bent out of shape now. I'm trying to be super intentional about what I say because it's like x's and y's are really different. It's a mirror image of your positive x's. Bless you. So let's do this. What is not going to change are where's my original graph? Okay. Here are my original points. I've got so many points on here. What is not going to change in terms of my x's are my positive x's. So I'm going to do this group first. I'm going to take all of those numbers. I'm going to keep my x's the same, and I'm going to flip my y values, okay? So all I'm going to do is flip my y values, keep my x's the same. And I'll do this over here. I'm going to leave a little bit of room because I've got to deal with those negative x's later. But 0 is fine. Oh, let me zoom back out. I don't remember any of my numbers. Okay, 0 is fine. That -2 becomes a +2. 1 and 0 are good. 2, and then that negative or +1 becomes negative. And then 3 and that +1 becomes negative. I have now done my -1 times my y's, and I've done all my positive x's. Now, what happens here is when I have the absolute value around the x, when I plug -1 in, that's the same thing as plugging in what? +1. Very good. And what is my y value for +1? 0. So when I plug -1 in, that's the same thing as plugging in +1, and it's y that goes with it is 0. So I will have a point at -1, but it's not my normal -1 point. I'll have a point at -2. It's not your normal -2 point. It's the same thing as your +1 and your +2 and your +3. So we're going to do that for all of these. Just erase that. Okay, so now I'm going to mirror all of these. So instead of putting in a -2, I put in a -2, and that's the same thing as having a +2. And what would my y value then be? -1. So my y value for -2 is the same thing as my y value for +2.
Okay, this explains so much. That's kind of what I was confusing yesterday. I was like, hold up.
It's still a little funky, and we'll still do a few more examples if you're still not there, but like that's kind of all we're doing. We got to do one more. Now we got to do the 3. I know I see you, Max. I'm going to get you in a second. If I do absolute value of -3, that's the same thing as plugging in 3. And if I plug in 3, what would my y value be? -1. Still have a question?
Why is -3 and -2 the same line?
They have the same point because up here, my +1, my +2, and my +3 have the same point.
But is that like a function or is that still a function?
Yep, it was a function given to us.
Okay.
I had to tell you what those points were. We didn't make those up. All right, now let's graph it. So I'm gonna graph these. Maybe I can fit them in here. I've got like a fatter marker going on so I can zoom out a little bit and still write, but it's not too fat. Okay, so I'm gonna graph all those points I just did. -3, -1, -2, -1, -1, 0, 0, 2, 1, 0, 2, -1, 3, -1. Kind of a poor drawing, but it's good enough. One thing, oh yes, Zach.
I'm a little confused because I thought the absolute value meant there could be any negative x's.
So there are no negative x's. I can still plug in a negative. What's just going to happen is it will come out to be a positive value. So unlike y's, when we do the like absolute value of f of x, the problem there is that I do my whole function out and then I have to make that very last number a positive number. This is not the case. The very first number I'm putting in has to be coded to positive. So then I have to make sure like these all code up and match together. That's a great question. Okay, that is my graph. All right, we're technically done with our notes, but I feel like we could use a little bit more work on these kind of problems. Am I correct?
Yeah.
Okay. I'm team time outing right now to remind you that your 1.6 homework is due next time I see you. And the paper I'm about to give you is not ever going to be due, but do I think it's helpful to do? Yes, hence why I'm passing it out. So I have it on Schoology. I'll put it online right now, but I'm going to make everybody take a paper copy of this. What I want you to do is the first 9, there's like 9 little handwritten problems at the top of the page. Sorry, that's lame. I wasn't going to type it up. I want you to do those first. It tells me, it asks you to describe the transformation. So does it go up 1? Does it stretch by 2? Does it flip? How does it flip? Those kind of things I want you to tell me in the first 9. I'll have you work on that. We'll pause, come back, go over it. And then I'm going to have you work on the first few, pause on your own. We'll talk about it. I'll flip you over to the back, work on a couple on your own. We'll talk about it on your own, talk about it. Does that make sense? We're doing a lot of bouncing around today. If we have any extra time, if we finish this whole sheet, that would be awesome. And I'll let you work on your homework. But until then, we're going to start on the first 9. If ever you are done and I'm not ready to talk about it yet, I want you to just keep moving. Keep on swimming. Pass the papers back to them for you. Then it puts over the x-axis. That's when it puts over the y-axis. I've got a lot of papers. It's because of Paige and Al and Jane all need one. There might be an extra one back with you guys, but I promise Maggie to give your friends some papers. Don't be afraid to work with a neighbor. So on these first 9, I want you to work with a neighbor. I'm going to keep the Zoom recording going because we're going to keep coming back and forth, but there's going to be some dead time, so you can have to skip ahead if you're working on your own. Too many papers.
+1, no parentheses, up and down.
Yes.
The classroom.
Say that one more time.
Michael Bedelli in the classroom.
Yes, he is. I assume that. I assume that he's going to student services. That's a wild call. Is he in the classroom and then he just like peeps out? Okay, everybody has a paper? Good. I would love for you to talk to each other. I'd love for you to do it silently. Whatever makes you happy. Go do those first 9. Yeah. I do. Yes. Of course, I meant to pass it back the other day, and then I just forgot.
have a question. So, would this be these points for everyone?
Yes, but I want you not to do that. I want you to do the first 9. The first 9 are not required you to use this. I want you. These are like by themselves. So like I want you to look at that and like how does just how does that change it? Like does it move it up, down, vertical stretch? Do you multiply the y's by something?
Okay.
Barrett, you working on this? All your 9 are done. I do have some papers I've been neglecting to pass out, so I'm gonna pass those out right now.
Billy.
Your left fork, but the numbers in front are multiplying, not moving up and down. So I would say like you could say that's a vertical stretch of 2, or you can say that's like 2 times 1. But we're not moving up to the up and down is attached to the end. Yeah. That's why you asked. You want to hold on to that to success? I do have that's why they hired me. She writes pretty and she uses colors. That's what you were. Oh my god. Oh, I did not mean that was rude. I did not mean to do that. I'm so sorry. All right, can we take like another minute or 2 and then talk about these? Vertical stretch. You say vertical stretch, right? Let's see if I wrote 2y there. You can write 2y. And that will also look. I'll be back.
What you're doing is going to just go to the bottom.
No, sign it.
It doesn't matter.
I had not marked you guys off. It should start at the top. No. For close circuits at the top. This is the perfect test. Your second graph is you're going up, but I have not seen constant points because it's actually more technical that
Bro, why not go shooting?
All right, let's find a stopping point. Let's talk about these. Let's talk about these. Okay. First one. Let's make this a little bit smaller here. All right, what is going on here? What's happening on number 1? Vertical stretch. And which variable does that affect? Choose the y, so I'm gonna do 2 times y. This little, like, I'm gonna do like 2 times y or 1 minus x or whatever. That is like, I think the most helpful thing. The vertical stretch doesn't really tell me a lot, but what I'm doing to my variables, I think is really helpful. Because if it's an A, if it's a number out front, then that stretches my graph vertically or shrinks it vertically. If it, nope, then that's the B. Then that does it horizontally. Good question. Horizontal is the B. What about the next one? Negative x to the third. What does that do to my graph? Max?
Oh, it's opposite.
We flip it over which axis? The x-axis. Good. And which variable does that change? Your x's or your y's? Your y's. So it's like we're doing -1 times y. Okay. Questions yet? What about the next one? What's my change here? Down 7. And which does that affect my x's or my y's? Y's, good. Y minus 7. Okay. First 3 are done. Anybody questions yet? We just start building off of this. So if this is hard, I would sit down and figure out what the changes are. If you can't figure out what the change is, then it's going to be really hard to move the points and do all the changes with those. Okay, let's move to number 4. What's going on with number 4? It goes right 2. Does that affect my x's or my y's? X's. So I'm going to do x plus 2. What about 5? I've got 2 things going on here. What does that negative do? Flips over what? X-axis. Good. What is that? Which variable is that?
Negative y.
Good. My y's go negative. And then what about this plus 4? What's that? Left 4. So how do I change? Do I change my x's or my y's? I change my x's. I do x minus 4. Very good. How are we doing? Am I moving too fast or are we good? We're good? Okay. Steady pace. What about number 6 then? What's going on here? What did you say, Barrett?
The skew.
It's not a skew.
Stretch.
We can call it a shrink. Shrink. What does the shrinking? What makes it shrink? The 1/3 or the 1? The 1/3 makes it shrink. It's a vertical shrink because technically I'm going to multiply my y's by 1/3. So whatever that A is, you are going to do that number times your y. So 1/3 times y should shrink my numbers by a factor of 1/3. It should make them a little smaller. Billy. Yes, Max.
Can you like draw what this would look like?
I'm going to draw what other ones look like.
Like a vertical shrink. Literally just go.
It literally just like shrinks up. So like if I'm looking at this graph right here, a vertical shrink. I don't know if I have this on here. If I did it by a factor of 1/2, it would still, all my zeros would still be at the same spot, but all my y values would be divided by 2, so they'd be a little bit tighter. So instead of being at -2, I'd be at -1, and instead of being at 4, I'd be at 2, and this is at 3, so I'd be at like 3/2. So see how it's just like it's like a little crunch.
It's a third short.
It's like I made it a little bit tinier.
It's like that.
Okay. Does that help your vertical shrink
Yeah.
question? Great. All right, what about the 1? What does that do to my graph? Up 1, good. Is that my x's or my y's? Y's, good. Okay, now my question for you is if I have a multiply and a plus like this situation, which do I do first? Multiply. You're gonna do any multiplying, whether it's times -1, whether it's times 1/3, whether it's times 2, you're gonna do any multiplying and then we can add or subtract. Okay, always multiply first. Questions yet? Okay, next 3. Ooh, this next one's got a lot. What's going on here? What's one thing that's happening?
Vertical stretch.
Vertical stretch of 4. How do I do that? Which variable does that affect? Y, so 4 times y. Good. All right, what's another thing that's happening here?
Right.
Right one.
Right 1, which does what to my which variable? X plus 1, very good. What's the last thing that's happening?
Up 7.
Up 7, which affects my which variable? Y plus 7. Great.
Do you have to write though?
Nope. On this one, I want you to write at least one of these things. On my transformation graphs, I'm probably going to write the highlighted part because that's the most helpful. These little things right here are way more helpful to me than up 7, because it tells me I'm physically adding 7 to my y's, or I'm physically multiplying my y's by 4. Yes, Max.
So whenever there's that like the +7 outside of the parentheses, that's always going to be a y.
That's always a y.
And then the inside's going to be.
And that's the same thing. See how my 4 is outside the parentheses and it's affecting my y's, and my 7's outside the parentheses and that's affecting my y's. Everything outside you do to your y's. Everything inside parentheses you do to your x's. If there's no parentheses like an 8, is there anything inside? No. If there are physically no parentheses, just nothing is inside the parentheses. Everything is outside the parentheses. So that being said, what's one thing that's happening in number 8? Stretch. Good. Stretching of 3. We're going to multiply all of our y's by 3.
And we're going down 4.
And we're going down 4. Which means we're going to do y minus 4. All right, last one. What's going on here? Up 2. Y plus 2. And then left 3, you said? Okay. X minus 3. I find it really helpful to kind of pause and go over this first, because if we're not all talking about the same things when we're doing this, then we're going to have different answers when we get to the actual graph. I don't think these graphs are super hard. I just think there's a lot of room for error. So you just have to be really careful and intentional about it. Remember, I'm going to put this on your quiz. I'm not putting 1-7 on your quiz. So there will be graph transformations. Maybe not like 17 like on this paper, but there'll be at least 1 or 2 or 3. So we got to be prepared to do that. Okay. Now, underneath this is my graph that I gave you. So this is my normal function. This is my f of x. What I would do first is make your little t-table, and then I would go do all of our transformations. Do you guys like doing the little t-table?
Yes.
Okay, good. Can I maybe be quiet for another couple minutes and you guys try some, and then I'll show you answers and we'll talk about if we have any questions? Does that work? Okay. Feel free to talk with the neighbor. Feel free to work with each other. Now's a great time. Or feel free to do it by yourself. It does not matter to me. So, but I'm going to be quiet for a minute. You guys work.
What?
Be nice to each other, please.
Yeah, I need the bathroom.
One second. I got to do attendance before. Yeah. Yeah, thank you. I'll put an answer key for that on mine. Hey, you too. You forgot what time of day it was.
Yeah, I was just like, hold on. It's afternoon right now. Like,
It was lunchtime. I said good morning to someone. They looked at me funny. I was like,
I
sorry.
It's okay. I told someone good morning at 8 p.m. one time.
Ah.
So
That's all right.
But
It's still nice
this
wishes.
way.
Bye, Ava. Sophia's not here. Sophia's not retreat. Again, everyone who's supposed to be here is here. I'm going to start doing the first couple on my screen, and then we can pause and talk about them momentarily. Okay, so I got my first one on the board if you want to check yours in. That. You've done the first three, go to the back side. Does anyone have any questions on the one that you see? Any questions on? Okay, I'm gonna work on the next one then. Remember to do your multiplying first. I'm gonna do all my multiplying and then I'll add them. I've got my second one up if anyone needs to check that. I did all my multiplying first and then I added all my ones to it. So I essentially did 2 steps. So Zach asked a good question. He's like, why did you cross all the Y's out and make different numbers? I always multiply before I add. So I did all my adding, or I did all my multiplying first, and then I went through and I added 1 to all of those numbers. If you can do it in your head, awesome. If you don't like crossing it out and you just want to make a new t-table, go for it. I'm kind of like in between the fact I can't do both in my head, but I'm also refusing to do a second table. So that's why I'm crossing. I like to kind of pause at this point to say, make sure that you do kind of like a does this make sense test to yourself. So like if I'm looking at this graph and I know that I was supposed to flip it, my first question is, does it look like I flipped it? Does it look like I flipped it? Yeah, it does look like I flipped it, right? And then I also know I'm supposed to move it up 1. Does it look like everything's moved up 1? It also does look like that. So that's my kind of does this make sense test I do. If you're like, I don't understand how this test works, let me know and I can like kind of sit and walk through you. But like, if you know what the transformations are and you know what it looks like to flip or to move up 1 or move right 5, you should be able to look at your graph and say, yeah, this looks similar to what I got. Every so often I'll give a test or a quiz or something and someone will have some like totally different figure than like what I started with. Like they'll get something on this next graph that's like flat and then like backwards like this. And you're like, how did you get that? We still need some peaks and valleys if I had peaks and valleys here, right? It should still somewhat look like what we've had going on to begin with. So that's another test you can do. Does this kind of make sense? Yes or no? Yes. You have to have something to start with. If I just wrote like this right here, you don't know what to do. You don't know what points you're doing that with, so I have to give you something to start with. Okay, so I'm going to move on to the next one. I'll be quiet again while I solve this one. A little bit hanging off the graph, but that's okay. So this one I didn't do any flipping. All I did was move right and down. I think I literally just took my graph, but I just moved it right and I moved it down. Okay, so we've done 3 on the front side. Anybody have any questions yet? Okay, we're working on the back side. I don't think we're going to be able to do all 6 of them. Are there any that you're like, I really want to see this before I leave? Look at all 6 on the back side. Are there any on that back side that you're like, I really would like us to talk about before I leave? Zach, what are you thinking?
2, 3.
The second one and the third one? Okay, the difference between those 2. Yep, those will go pretty quick. And then I can guarantee I can probably do at least one more. Sterling? Yep, the fraction one. Good, okay. I'm going to do those first. So I'm going to do the 2 absolute value one, and then I will do the fraction one, okay? You can work at your own pace still. You don't have to listen to me. I'm just trying to get at least those done. Let me copy my points from the other side over to this side. Okay, give me the first absolute value where I'm just doing absolute value of f of x. So again, that whole function's good. The only thing that's a problem is if my y is negative. And the only y that was negative that I had to change to be positive was my original point was 2, -2. And when I do absolute value, it becomes 2, +2. So everything is the same, except I just bring that 2, -2 point up, and it's just like little bitty mountaintops. Does that make sense? That wasn't too hard. That was pretty good. The next one is the harder one, though. So I kind of gave us a little T-ball soft throw. Now we got to do a harder one. Okay. This one, remember when it's absolute value of just x, I am good with all the positive x's, and then I want the positive x's to mirror for my negative x's. So I'm going to go draw all of these. I'm going to write these points. None of these points change because there's no other transformation. All that happens is all of those points stay the same. Bless you. I'm going to give myself a little bit of space because I will need some negative points. So I'll do 0, 0 stays the same. 2, -2 stays the same. 4, 0 is good. 7, 3 is good. 10, 0 is good. Now what happens here is we're doing the absolute value of an x to get an answer. I'll do absolute value of -4 first, but there are other points that I will do between that and 0. So absolute value of -4, what is that? +4, right? So when I put -4 up here on my t table, I need it to match my +4's y down here. So when I plug in -4, I essentially am doing the same thing as plugging in +4. So when I plug in -4, I get out 0, just like what would happen if I plugged in +4. Okay. I left a little bit of space there because we're not just going to do all the points that I have on my negative side, because I don't really know what, if I were to do -8, I don't know what point I would get if I plugged in +8, because I don't have that on this side. But I can plug in a couple points that I didn't have before because I do have their points now. I can plug in -2, I can plug in -7, and I can plug in -10 because I know what their positive values give, so I know what all their y's are. So I can plug -2 into this picture, into this equation, because the absolute value of -2 is +2, and I know what that y is. What is that y? -2. I can do -7 because the absolute value of -7 is +7. And what's my y value at +7? 3. And then last I'll do absolute value of -10 because we can do +10. What would my y value there be? 0. I'm going to graph all the positive x's first, and then I'm going to show you how it's a mirror. So I'm going to do 0, 0, 2, -2, 4, 0, 7, 3, and 10, 0. This side doesn't change, this side is good. Okay. Now, I know that the absolute value says no negative x's, but that's like the same thing as if I plug these negative x's in, it gives me out a positive x. So I'm going to go graph my -2, -2. I'm going to graph my -4, 0, my 7, 3, and my 10, 0. See how they're mirror images of each other. I know you're packing up, but I am going to talk through what I'm going to do on the next problem, and then I'll do it and put it online. This next problem, what does this 4 do? I think we all know what that 4 does, right? Up 4, so it's like I'm doing y plus 4. And this 1/2 does opposite of what I think it should do. So if it was on the outside, you would say, oh, well, we'll multiply all of our y's by 1/2, right? Instead, I'm going to do the reciprocal. I'm going to do the opposite. I'm not going to multiply by 1/2. I'm going to multiply all my x's by 2. What that's going to do is really stretch my graph out wide. None of the y's get taller or shorter. It just gets really stretched out. I'm gonna multiply all my x's by 2. I'm gonna add all my y's to 4, and I will get my new answers.
Hope you had a great day today. Let's keep in our prayers the juniors that are up in South Bend for their junior retreat overnight tonight. Keep them in our minds today as we end the day with our traditional prayer. Please join me today. In the name of the Father, and the Son, and the Holy Spirit. Hail Mary, full of grace, the Lord is with you. Blessed art thou among women. Blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. Father, the Son, and the Holy Spirit. Amen. Amen.
All right,
God
you're
bless you.
1.62. See ya.
Bye.
Thank you.
Bye, thank you. So that's the graph, those are the points I got. Yeah. It is in front of that. We just have we have an actual function in here. See how that's an x to the third? So our f of x is x to the third. Oh, okay. So I just had a generic function there, but now I actually gave the function. Okay. So that 2 is technically in front of the f. See how he's still outside? He's not inside. Yeah.
Can I take a test tomorrow?
Yeah. That would be great.